Hello, YouTube. This is Mr. Bakari, and today we are going to look at evaluating logarithms. Okay, so we're going to look at about 8 or 9 examples here, and as we kind of move along, they will progress in a little bit of difficulty. But I just want to try and cover every kind of scenario that you might see when you start dealing with evaluating logs. All right. So we have 9 examples over here we're going to go through. Over to the right, I've brought in some exponent rules you're going to want to recall as we go through these. So I'll refer to them as they come along. So let's look at our first one here. And as I write it down, let's talk about what we're trying to do here. So a logarithm asks what exponent gives this result. So when we evaluate a log, we are finding the exponent. There's no variable in the expression, okay? We're just giving what exponent is equal to this log. And the easiest way to do that is to set your log equal to x and rewrite it in exponential form, okay? And how we do that is we keep the base and we flip the argument and the exponent, okay? So that would be 2 to the x equals 32. And now when you look at it like this, you can clearly see what you're trying to achieve here. What power would I raise 2 to get 32? And that would just be 5. So your answer is 5. Okay? And it's that simple. All right, so let's look at the second one. Log base 3 of 81. So I'll do the exact same thing here. I'll set it equal to x. I'll rewrite it in exponential form. And I'm looking for the exponent I would raise 3 to get 81. 3 to the fourth power is 81. X equals 4. So my second one is 4. All right. Moving on to the third one here. Log base 5 of 1. Okay, same thing. What would I raise 5 to get a 1? Well, you might want to recall the zero exponent rule, which states that anything raised to the zero power will give you a 1. Okay, so that means x must be 0. All right. Now, number 4, a little bit different. Okay, so we're looking for an exponent of 4. 4 raised to what power will give us 1/16th? So we're starting with a whole number and we're ending up with a fraction. When you see this, or vice versa, you start with a fraction and end up with a whole, you want to think reciprocal. And reciprocal brings us to negative exponents. Okay? So we know that 4 squared is 16. So that must mean that x is negative 2. Okay? So now look at the negative exponent rule over here. And a negative exponent means take the reciprocal of the base and make the exponent positive. Okay, and that's exactly what we do here. All right, 4 to the negative 2, we take the reciprocal, which would be 1/4, and we make the exponent positive, which would give us 1/16th. All right, so number 4 is negative 2. All right. Number 5, log base 3 of 20. Okay, what would I raise 3 to get 20? Well, we run into an issue here because there's no rational number you can raise 3 to get a 20. So what that tells us is that the exponent is irrational. Okay? So this is the exact answer. We could make an estimation with a calculator, we could round it, but that's all we can do. Okay. So this is our exact answer. Okay. You can think about that one as you're not going to evaluate it or change it without a calculator unless you just want to make an estimation. Okay, number 6, natural log of e to the fourth over e. Okay, so here we want to refer to the quotient rule, right? Which says if you divide the same base, you subtract the exponents. So this can be rewritten as natural log of e to the third. Okay, now set that equal to x, and let's rewrite this. Now, let's recall that our natural log has a base of e. We don't write it, but it has a base of e. So when we rewrite this in exponential form, it would just be e to the x equals e to the third. Now, we have a common base on each side, so we can set the exponents equal, which means x is 3. Okay? All right. Moving on. Number 7, log base 2 of 16 plus log base 2 of 2. Now here I can just simply evaluate each log and add them together. Okay? So now hopefully by now we don't need to rewrite this. We can just look at a log and we see that it's saying, what would I raise 2 to get 16? And the answer would be 4. What would I raise 2 to get 2? And that would be 1. So 4 plus 1 is 5. And now we have evaluated number 7. All right, number 8, log base 32 of 2. All right, so let's take a look at this one. 32 to what power will give us a 2? So when the base is larger than the result, we want to look for the exponent to be a fraction. Okay? So when I say that, we want to kind of hone in on the rational exponent rule because a rational exponent can also be written as a radical. So we could also think of what root of 32 would give us 2. Well, the fifth root of 32 is 2. And if we write that as a rational exponent, it would be 1/5. So x is equal to 1/5. Now, let's kind of take our time with this and let's look at this rule. So let's look at this rational exponent rule over here. So when converting a radical to a rational exponent, the index becomes the denominator and the exponent of the radicand becomes the numerator. Okay, that's what it's showing us over there on the right. Now the radicand is the number under the radical. So that would be a in this example. Okay. So we're going to walk through this slowly with the last one here. So it says log base 3 of the fourth root of 3. So if I write that 3 to the x equals fourth root of 3. Okay, so now using this exponent rule, we can rewrite a radical as a rational exponent. Okay, so let me tell you this again. The index becomes the denominator. So the index is 4. Okay. All right. And the exponent of the radicand becomes the numerator. Well, the radicand is 3, and as you can see, it's raised to the first power. That becomes the numerator. So the fourth root of 3 is simply just 3 to the 1/4. Now, if we bring that over here, just like so, we can see that we have a common base, and x equals 1/4. Okay? So knowing these rules over here is really important when you're evaluating logs because they come up. So you need to know them. All right. So hopefully this gives you a good idea of how to evaluate logs. And come see me in the next video where we talk about log properties and we kind of expand on simplifying, condensing, expanding, and eventually solving log equations. Hope to see you there.